Hey guys, Elmer the exponential elephant here, talking to you about multiplication properties of exponents. Now here's the question. Why couldn't the elephant use the computer? It was afraid of the mouse.
First thing we're going to talk about are exponents. So exponents, if you recall, it's something raised to a power. Now that something is called your base, and that power is called your exponent. And the exponent tells you how many times to multiply the base by itself. So here we have 4 to the third power. Now 4 to the third power just means you're going to take 4 and multiply it by itself 3 times. So 4 times 4 times 4. Now how do we do that? Well, 4 times 4 we know is 16, and then 16 times 4 is 64. So that's how you do that. Next thing we're going to talk about is scientific notation. So scientific notation is a method of writing really large and really small numbers. Scientific notation is written in the form a times 10 to the nth power, where 1 is less than or equal to a, which is less than 10, and n is an integer. So when you're writing a number in scientific notation, when you're converting it into scientific notation, this number in front has to be a number that is greater than or equal to 1, but less than 10. Now let's say your number that you're converting in scientific notation is really big, like 5 million. Well then, your n, your exponent, will be a positive integer. If you're converting a number that's really small, like really close to 0, like 0.00001, that means that your n, your exponent for 10, is going to be a negative integer. Next thing we're going to talk about is multiplying powers with the same base. So to multiply powers with the same base, all you have to do is add the exponents together. So here we have a to the x power times a to the y power. Now all you do when you have two bases that are the same and you're multiplying is you add the two exponents together. So here a to the x times a to the y equals a to the x plus y power.
What's big and gray and nobody talks about it? The elephant in the room. Example time.
So example 1 says rewrite the given expression using each base only once. So here we have 7 to the 4th power times 7 to the negative 2nd power. So when we're simplifying this, we want to rewrite it so it's going to be 7 to the, and then what is our new power? Well, again, when you're multiplying like bases, you're going to add the exponents together. So 7 to the 4th times 7 to the negative 2nd, you add 4 plus negative 2, which is the same thing as 4 minus 2, and you get 7 to the 2nd power. For b, we have negative 5 to the 9th power times negative 5 to the 4th power times negative 5 to the negative 1st power. So again, when multiplying like bases, you just add the exponents together. So here, what's 9 plus 4? That's 13. And then what's 13 plus negative 1? Well, it's 13 minus 1, which is 12. So your answer is negative 5 to the 12th power. Here we have 10 to the x times 10 to the y. Again, multiplying like bases, you just add the exponents together. So here this would be 10 to the x plus y. What's x plus y? Well, it's x plus y. You can't simplify that any further. So your answer is 10 to the x plus y power. Here we have x squared times x cubed. So x to the 2nd times x to the 3rd, again, same base, which means we just add the exponents together. So x to the 2nd times x to the 3rd is going to give you x to the 5th power.
What do you get when you cross a herd of elephants and a group of fish? Swimming trunks. You try.
Okay, doing the same thing here. We have negative 8 to the negative 4th power times negative 8 to the 2nd power. So again, like bases, we just add the exponents together. What's negative 4 plus 2? That's going to be negative 2. So this is going to be negative 8 to the negative 2nd power. Here, 20 to the 100th power times 20 to the negative 50th power times 20 to the negative 49th power. All right, these are some bigger numbers. So again, multiplying like bases, we just add the exponents together. What's 100 plus negative 50? That's the same thing as 100 minus 50, which is 50. And then we have 50 minus 49, or 50 plus negative 49. That's going to be 1. So this is going to be 20 to the 1st power, or just 20. Here, 12 to the x times 12 to the x. How do we do this? Like bases, when you're multiplying them, you add the exponents. What's x plus x? That's going to be 2x. So this is going to be 12 to the 2x power. And then lastly, we have x to the 5th times y to the negative 2nd. Well, here you can see these bases are not the same. So we don't have like bases, which means we're not going to add the exponents together. We just leave this x to the 5th times y to the negative 2nd. Now example 2 says complete each equation. Here we have 7 to the 4th times 7 to the something power equals 7 to the 12th power. Again, when you multiply like bases, you just add the exponents. So basically, this is just a puzzle. 4 plus what equals 12? Well, you could either guess and check, or you can take 12, subtract 4, and that'll tell you what this is going to be. So what's 12 minus 4? That's 8. So this is going to be 7 to the 8th power. And that makes sense, right? 7 to the 4th times 7 to the 8th. 4 plus 8 equals 12. Here we have 9 to the something power times 9 to the 10th power equals 9 to the 4th power. Again, we have like bases, so we just add these two exponents together and it's going to equal 4. Well, that's interesting because this is 10, which means that this should be a negative exponent because this plus 10 would have to equal 4. So how do we figure out what that is? Well, you can guess a check, or you can take 4, subtract 10, and you get negative 6. That gives you what's going to be here. So this is going to be 9 to the negative 6th power. And let's double check. What's negative 6 plus 10? That's 4. Here, a to the negative 20th times a to the negative 30th equals a to the what? Well, again, multiplying like bases, you just add the exponents together. What's negative 20 plus negative 30? That's going to be negative 50, and you're done. Lastly, we have x times y to the something times x to the 8th times y to the 3rd equals x to the something times y to the negative 6. Okay, so all of these are basically being multiplied together. So what we can do is deal with the x's first, and then we'll deal with the y's. So x by itself is the same thing as x to the 1st power, right? So this is going to be x to the 1st times x to the 8th. Now what's 1 plus 8? That's going to be 9. So over here, this should be x to the 9th power. Now let's deal with the y's. So it's going to be y to the something times y to the 3rd equals y to the negative 6. That means that this plus 3 has to equal negative 6. Now you could guess a check, or you could take negative 6 and subtract 3. And that should give us what's over here. So what's negative 6 minus 3? That's going to be negative 9. So y to the negative 9th should be our answer here. Now let's make sure that makes sense. Y to the negative 9th times y to the 3rd. So what's negative 9 plus 3? That's negative 6. And you're done.
How do you make an elephant fly? Start with a 3-foot-long zipper. You try.
Okay, doing the same thing here. So we have negative 2 to the 2nd power times negative 2 to some power equals negative 2 to the 7th. Again, multiplying like bases, you're going to add these exponents together. So this plus this should equal 7. Now you could guess a check, or you could take 7, subtract 2, and you should get 5 as your exponent here. Does that make sense? 2 plus 5? Yes, that equals 7. For part B, we have 3 to some power times 3 to the negative 10th equals 3. What's the exponent for 3? Well, again, since there is no exponent, it's just 1. That means that something plus negative 10 has to equal 1. Well, what's that something? Well, it's going to be 11, right? Because 11 plus negative 10 equals 1. You could have taken 1 and subtracted negative 10, which is the same thing as 1 plus positive 10, and that is how you get 11. Here, q to the negative 4th times q to the negative 5th equals q to the what? Well, again, multiplying like bases, you just add the exponents together. What's negative 4 plus negative 5? That's going to be negative 9. And then here we have m to some power times n to the 6th times m to the 17th times n to the 29th equals m to the 15th times n to the what power. So again, since it's all multiplication here, we can take it one step at a time. We're going to start with the m's. So m to what power times n to the 17th equals m to the 15th. Well, that means this plus 17 has to equal 15. So this should be a negative number, like negative 2. You could have also got that by taking 15 and subtracting 17. And again, you get m to the negative 2nd power. Now let's do the n's. So n to the 6th times n to the 29th. You're going to multiply like bases, so you add the exponents together. What's 6 plus 29? That's going to be 35. Now, example 3, we're going to simplify each expression. So we're doing the same thing here, except we're simplifying, which means our answers should be more simplified than they were. We can't have any negative exponents, stuff like that. Okay, so here's what we're going to do. We have 5c to the 3rd times c to the negative 1st. So when you're multiplying like bases, like these c's, you're going to add the exponents together. So what's 3 plus negative 1? That's the same thing as 3 minus 1. So it's going to be 2. So this is going to be 5c to the 2nd power. Here, we have 8h to the 6th times negative 2h to the 4th. So here, when you're multiplying two monomials together like this, you're going to take the 8 and the negative 2 and multiply those together. So what's 8 times negative 2? That's going to be negative 16. Now what's h to the 6th times h to the 4th? Well, again, multiplying like bases, you add those exponents together. So what's 6 plus 4? That's going to be 10. So it's going to be negative 16 h to the 10th power. Here, we're going to multiply these two together. Now, again, since it's all multiplication here, what we want to do is we're going to take it one variable at a time. What's x to the 5th times x to the negative 6th? Well, since you're multiplying like bases, you add the exponents. So it's going to be x to the, what's 5 plus negative 6? same thing as 5 minus 6, that's negative 1. And then y to the 10th times y to the 9th, we multiply those like bases together, so we add the exponents, that's going to be y to the 19th power. So we get x to the negative first, y to the 19th. Now, because we're simplifying this expression, we can't leave a negative exponent in our answer. So what we're going to do is we're going to take this, and we remember what to do with negative exponents now. To make it a positive exponent, we move it to the opposite side of the fraction bar. So it's going to be y to the 19th on top, and this x to the negative first comes to the bottom and becomes x to the positive first, or just x. Next, we have 2a to the 6th times 7b to the negative second times negative 3a to the third. So what we want to do here is multiply all the coefficients together, and then we'll multiply the variables together. So 2 times 7 is going to give us 14, and then 14 times negative 3 is going to be negative 42. Next, we multiply a to the 6th times b to the negative second. Well, this is a, this is b, so those are not like bases, which means we're not going to add those exponents together. We just leave it a to the 6th times b to the negative second. Well, what about a to the 6th times a to the third? Those are like bases, so yeah, we can add those exponents together. So a to the 6th times a to the third is going to be a to the 9th power. So this becomes negative 42, a to the 9th, b to the negative second. Now again, we can't have a negative exponent in our answer, so to make this a positive exponent, we just move it to the opposite side of the fraction bar down here. So it becomes negative 42, a to the 9th on top, and then b to the positive second power on the denominator.
What did the elephant do when he hurt his toe? Called a tow truck. You try.
Okay, doing the same thing here. So negative 4q to the negative 11th multiplying 2q to the 5th power. So q to the negative 11th times q to the 5th. Multiplying like bases, you just add the exponents together. So it's negative 11 plus 5. That's going to be negative 6. So we get negative 4q to the negative 6th power. Now again, since we're simplifying this expression, we can't leave it with a negative exponent. So we take this guy, move it to the denominator where it becomes a positive exponent. Next, negative 2.4r to the 4th times 2r to the negative first power. So anytime you have stuff with coefficients out front, we want to multiply those together first, and then we'll multiply the variables together. So negative 2.4 times 2 is going to be negative 4.8. And then r to the 4th times r to the negative first, since they're like bases, we add the exponents together. What's 4 plus negative 1? That's the same thing as 4 minus 1, which is going to be 3. So we get negative 4.8r cubed. Here, we're going to multiply each of these three monomials together. Again, multiply the coefficients out front first. So what's 9 times, there's nothing here, so that's just a 1, times 3, that's going to be 27. Then we go to the w's. W to the 3rd times w to the 1st, right? We add those exponents together. That becomes w to the 4th power. And then w to the 4th times w to the 5th. We add those exponents together. We get w to the 9th power. Then we do the e's, e to the 1st, because there's nothing here, times e to the negative 4th. We add the exponents together, so what's 1 plus negative 4? That's the same thing as 1 minus 4, so that would be negative 3. So we end up getting 27 w to the 9th, e to the negative 3rd power. Again, since we're simplifying this expression, we can't leave a negative exponent in our answer, so we go ahead and take this e to the negative 3rd, move it to the denominator, where it becomes a positive exponent. Lastly, we have negative m squared times 4r cubed times 12r to the negative 4th times 5m. So again, we want to multiply all of the coefficients together, then we'll deal with the variables. So here we have a negative 1 times 4 times 12 times 5. So that should be negative 240. Then we're going to do m to the negative 2nd times r cubed. Those are not like bases, so we can't add the exponents. Times r to the negative 4th. Those are not like bases, but these are. So we'll get back to that. And then m to the 2nd, we'll multiply it to this m that's out here. So m to the 2nd times m to the 1st. That's going to be m to the 3rd power because we add those exponents together. So we get m to the 3rd power. And then what about the r's? R cubed times r to the negative 4th. We multiply those like bases, so we add the exponents. What's 3 plus negative 4 or 3 minus 4? That's going to be negative 1. So we get r to the negative 1st power. So we get negative 240, m to the 3rd power, r to the negative 1st. And again, we're simplifying, so we can't have a negative exponent. So we take this r to the negative 1st because that's the only thing that has a negative exponent. We move it to the denominator where it becomes a positive 1st power. Next, we're going to talk about multiplying numbers in scientific notation. So to multiply two numbers in scientific notation, multiply the two numbers in front and add the exponents of each 10. So if we have a times 10 to the nth times b times 10 to the m power, what we want to do is multiply the a and the b and then add the exponents of the tens. So it looks something like this. Now again, you will have to reconvert it into scientific notation if a times b is not a number between 1 and 10. So example 4, we want to simplify each expression, write each answer in scientific notation. So just like we said, when you're multiplying two numbers in scientific notation, you want to multiply the numbers out front together. So what's 4 times 2? That's going to be 8. And then we want to add the exponents of the tens. So what's 5 plus 6? That's going to be 11. So it's going to be 8 times 10 to the 11th power. Let's try B. So B, we want to multiply the numbers out front together. So what's 7 times 3? That's 21. And then we're going to add the exponents for the tens. So what's 9 plus 4? That's going to be 13. So we get 21 times 10 to the 13th power. Now, the only problem is that we now have a number out front that is not between 1 and 10. So we have to make it between 1 and 10 because your answer has to be in scientific notation. So we move our decimal. Remember, if you don't see a decimal, it's at the end. You take that decimal and you move it to the left 1 decimal place. So you get 2.1. But when you move a decimal to the left, right, 1 place, you have to add 1 to your exponent of your 10. So this becomes 2.1 times 10 to the 14th power. That is putting it back into scientific notation. For part C, we're doing the same thing. We're multiplying the numbers out front, adding the exponents for the tens. So what's 6 times 2.5? That's 15. And then what's negative 4 plus negative 10? That's going to be negative 14. Now again, we want our answer in scientific notation, but this 15 is not a number between 1 and 10. So we have to take our decimal, move it 1 place to the left, just like we did. And when we move our decimal 1 place to the left, we have to add 1 to our exponent. So this is going to be 1.5 times 10 to the, what's negative 14 plus 1? That's going to be negative 13. And that's because when you take a negative and add a positive, it actually makes it negative 13. Now we have 0.4 times 10 to the 12th times 0.3 times 10 to the negative 5th. Again, multiply the numbers out front. What is 0.4 times 0.3? That's actually going to be 0.12. And then we're going to add the exponents of the tens. What's 12 plus negative 5? That's going to be 7. Now again, we have to make this number out front between 1 and 10. It's not. So we take this decimal place and move it 1 to the right this time. Now when you move a decimal place to the right, you're going to actually subtract 1 from your exponent here. And you end up getting 1.2 times 10 to the 6th power.
How do you raise a baby elephant? With a forklift. You try.
Okay, doing the same thing here. Multiply the numbers out front, add the exponents for the tens. So what's 9 times 1? That's going to be 9. What's negative 11 plus 7? That's going to be negative 4. And you're done. Here, what's 8 times 7? That's going to be 56. And then what's 18 plus 6? That's going to be 24. Now again, this has to be in scientific notation, so what we need to do is make this number out front between 1 and 10. So we take our decimal, move it 1 place to the left, and because you move your decimal place 1 place to the left, you're going to have to add 1 to your exponent. So this becomes 5.6 times 10 to the 25th power. Here, multiply our numbers out front. What's 15 times 22? That's going to be 330. And then we add our exponents together. What's negative 16 plus negative 11? That's negative 27. Now we need to make this number out front between 1 and 10. So we take our decimal, which is at the end here, and we're going to move it to the left 2 decimal places. Now when you move 2 decimal places to the left, you have to add 2 to your exponent here. Now what is negative 27 plus 2? That's actually going to be negative 25. So your answer is 3.3 times 10 to the negative 25th power. Lastly here, again, we multiply the numbers out front. What's 0.6 times 0.5? That's 0.30. And then you add the exponents of the tens. What's 2 plus negative 16? That's actually going to be negative 14. We need to convert it so it's in scientific notation. So we take this number out front, put it between 1 and 10. So we have to move the decimal place 1 place to the right, actually, this time. And when you move 1 place to the right, you actually subtract 1 from your exponent here. So this becomes 3 times 10 to the negative 15th power. Now our word problem says in chemistry, a mole is a unit of measure equal to 6.02 times 10 to the 23rd atoms of a substance. The mass of a single neon atom is about 3.35 times 10 to the negative 23rd grams. What is the mass of 2 moles of neon atoms? Write your answer in scientific notation. So in a word problem, step 1 is not being scared. We can do this. Step 2, we're going to define our variables. So what is this problem actually asking us? Well, it wants us to find, it says, what is the mass of 2 moles of neon atoms? So that means we're solving for the mass. So we'll say M is the total mass. And we also know that the mass of a single neon atom is about 3.35 times 10 to the negative 23rd grams. So we could say that N is the mass of a neon atom. So now when we want to write our equation, we need to figure out, what are we trying to find? It says, what is the mass of 2 moles moles of neon atoms. So our total mass, M, is going to be equal to 2 times the mass of a neon atom times a mole, right? Because we need 2 moles of neon atoms. So we're going to say M is going to be equal to 2 times a mole times our mass of a neon atom, which is N. But again, we didn't even really need N. What we can do is just take 3.35 times 10 to the negative 23rd and plug that in there. Sweet. So all we have to do now is just multiply this together and we end up getting the mass of 2 neon atoms. So what is 2 times 6.02 times 10 to the 23rd? How do we do this? Well, again, we multiply the 2 times the 6.02 and we end up getting 12.04. We don't have to convert this into scientific notation yet. Let's multiply it all out and then we can just do it all at the end. So how do we multiply two numbers in scientific notation? We multiply the numbers out front together and we add the exponents of the tens. So multiply these two numbers out front and then add the exponents of the tens. What's 23 plus negative 23? That's 0, actually. So now we're going to reconvert this into scientific notation because our answer needs to be in scientific notation. We move our decimal place 1 to the left, which means we add 1 to our exponent. So we end up getting 4.0334 times 10 to the first. What does that mean? What did we just find? Well, that's actually the mass of 2 moles of neon atoms. So the mass of 2 moles of neon atoms is 4.0334 times 10 to the first grams, and you're done.